Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about how to solve the problem based on IR spectroscopy, because we were discussing the IR spectroscopy. And everybody knows that spectroscopy means what? The interaction of electromagnetic radiation with matter is known as a spectroscopy, and IR spectroscopy is corresponding to functional group. And as we know that functional group means what? Site of reaction. Whenever the reagent is added, the changes are occur at a particular part of the organic compound, and that part is gone changing into another some other group. So that type of the particular site, that specific site is known as a functional group, and IR spectroscopy provide us the information about the functional group. There are number of different functional groups are present, and therefore spectroscopy help us to determine the what kind of the functional group actually present in the unknown organic compound. And all these spectroscopic, that chapter is almost we have covered starting from the basic, and we have studied this chapter in a very systematic way. And at the final stage, in the previous lecture, we have solved one of the problem based upon how to solve it. The basic, what are the basic thing required for the solution of problem, that we already discussed. So today what we are going to discuss, we are going to discuss the remaining problem, how to solve, so that student can be acquainted, or they can be familiar with the student will be experts in solving the problem based on that IR spectroscopy that we are going to discuss today. So let's see the second problem, second example of this. So we are solving the problem, so it will be the second problem. That is a question may be like this: an organic compound having molecular formula I think C3H6O, which is a molecular formula, shows IR absorption bands at 3300, 1620 and 990 and 910 per centimeter. Find out the structure of the compound. Find out the structure of the compound. Structure of the compound. If you read this problem carefully, the similar problem we have solved in our previous lecture. So now, what is the first things required for it? That, as we know that while answering this type of the question, first point required is a SOU. SOU means what? Sites of unsaturation. Site of unsaturation you have to calculate, and how to determine, how to find out site of unsaturation of any given organic compound if they provide us the molecular formula. By using that molecular formula, we can easily find out the number of site of unsaturation present in an organic compound. There are various methods to determine the site of unsaturation at T.Y.B.Sc level. Specifically, they have given two methods how to determine site of unsaturation. That two methods we already discussed in our previous lectures. So let me repeat it once again. What are those two methods which we have learned in our previous lecture? Method number one. So what is that? Which is the most commonly used method for the determination of the site of unsaturation of an organic compound? There are 3 points to remember. What are those 3 points? Number A, then suppose there is the A is the atom. Suppose oxygen atom, each oxygen and the sulfur atom is replaced by, or in a first method, each O and S is neglected. Means there is if suppose they are present in the given organic compound, you just neglect it, or you did not consider that one, so just neglect it. If each nitrogen atom is replaced by CH, and if halogen atoms are present in the third point, chlorine, bromine or iodine, then each is replaced by hydrogen atom. So this is the first method. And second method, what is the distinct point which will differ from second method? In the first point, each oxygen and sulfur atom, if they are present in the organic compound, you should replace it by CH2. That is the change only. Other 2 points remains as it is, whatever they are present in the first method. Means each nitrogen atom should be replaced by CH, each halogen atom, chlorine, bromine, iodine, should be replaced by hydrogen atom. And these are the two methods. By using these two methods, we can easily find out the site of unsaturation present in the given organic compound. let's begin here. Site of unsaturation, number of site of unsaturation present in these, because we know that even though it looks as a very simple molecular formula, in the beginning we have seen there are a number of possible isomers are present, and we have to find out the exact structure of the given organic compound. The IR spectroscopy help us to find out the correct structure of the organic compound by knowing the IR stretching frequencies. From that, the organic chemist immediately recognize, or they can determine the possible structure of that unknown compound just by identifying the IR stretching frequencies, and from that they can easily find out. So let us begin, and there is a general rule here how to calculate the site of unsaturation. We are going to use as a first method. If you see here, the molecular formula which is given here is a C3H6O. Concentrate at blackboard once you understood this. So now what I am doing here, I am applying the first method, because which is a commonly used method for the determination of sites of unsaturation. Let's see here, molecular formula containing oxygen atom. Now according to as a first method, first oxygen atom we can neglect it. After neglecting oxygen atom, what is the remaining there? There remains C3H6, that is remains there. And then as we know that we are determining as a site of unsaturation. Unsaturation means what? The organic compound containing how many number of, whether carbon-carbon double bond, carbon-oxygen double bond, or maybe as a ring is there or not. So that type of the thing we are determining over here, and for that the number of, suppose as a 2 hydrogen atom is less, it indicates that there is a one, there may be as a one ring may present, maybe as a 3-membered ring, 4-membered ring, 5-membered ring, 6-membered ring, or 7-membered ring, or there may be the possibility of containing carbon-carbon double bond, or maybe as a carbon-oxygen double bond, carbon-nitrogen. But here if you see this molecular formula, there is a no nitrogen atom containing. So let's see over here what is remaining. What I did here, I have neglected oxygen atom. This is a molecular formula, as we know that. This is a molecular formula which is given according to as a first method. I have removed, I have neglected oxygen atom, and I got here the molecular formula C3H6. Now as we know that according to the general formula of alkane, do you know that alkane means what? The organic compound having the general formula CnH2n plus 2 is known as alkane. This is a general formula of alkane. Means there is a no alkane means it is a saturated compound, and now we are determining as a site of unsaturation. Now here the general formula of alkane is this one, CnH2n. Now n means number of carbon atom you have to consider here. Look at here, here are 3 carbon atom. So put that 3 value in the given formula. The formula becomes C3H8, right? 2 into 3 is a 6 plus 2, 8. Total becomes as 8, right? After that C3H8, now this, after the neglecting that oxygen atom, we got the base formula C3H6. You have to, similar to as a mathematical, you can minus it, C3H6. Remember here C3 and C3, this C3 which is coming from here, this C3 from this. Now if you see here, don't count C3, C3 is get cancelled, but 8 minus 6, just remember as a 8 minus 6. So 8 minus 6, there is a 2, and that 2 is always divided by 2. Remember here, this divided by 2 means 2 get cancelled and you will get as a 1. It means that there is a one site of unsaturation is present. So in this way you have to calculate the site of unsaturation present in the given organic compound. This is a molecular formula. Here we have calculated the site of unsaturation, which we got is 1. How 1 comes? So you do this, you do like this, you will get as a, why we are dividing by 2? Always remember the value comes should be is round figure 1, 2, 3, 4, 5 likewise. So always remember there is no fraction at all, and that is the way to determine the site of unsaturation of the given compound. Now got it? Now let us see the second point, which is another one. So second point. Now look at here, second point, what you have to write here. Look at here. If you read this, an organic compound having molecular formula C3H6, that's it, okay, shows or indicate or suggests IR absorption band at, look at here, these are the absorption bands are given, and what these IR absorption bands suggest, or what they indicate, or what they shows, what kind of the functional group, because as we know that these IR tracing frequency is nothing but as a due to the presence of that particular functional groups, and therefore from these signals or from this band we can easily determine what kind of the functional group are present in the organic compounds. So let's begin with how to write that sentence is also as a very important one. Here you have to write like this: the IR absorption band, you can call it as a band, signal or peak. You can call it as a signal or peak, right? Band, signal or peak. The IR absorption band, peak or signal at let us see here at 3300 per centimeter, 3300 per centimeter. Indicate, what it indicate? It indicate or it shows or suggests, indicate presence of what? Indicate presence of, as we know that OH, then NH, then triple bond CH groups. Look at here. The IR absorption band at 3300 per centimeter shows presence of these different groups OH, NH, CH groups. Now look at here third one. If you observe this molecular formula carefully, what do you observe? There is no nitrogen atom found in the molecular formula, and therefore here you can write as a compound does not contain nitrogen atom, does not contain nitrogen atom, hence does not contain nitrogen atom, hence possibility of NH group is ruled out. Look at here. Why we are ruled out this possibility? Because we have observed the molecular formula is a C3H6O. No nitrogen atoms are present there, and therefore the possibility of that NH tracing frequency is absent over here. Now the fourth point, if you see here what we calculated, site of unsaturation is 1. So as compound contains, here you can write as compound contains only one sites of unsaturation, therefore possibility of triple bond CH is CH group is ruled out as compound contain only one site of unsaturation. Therefore possibility of triple bond CH group is ruled out, because if triple bond is there, triple bond accounts, because you can write here, because triple bond accounts for two sides of unsaturation, two sides of unsaturation, and therefore this possibility also ruled out. Now what is the next point? The fifth point you can mention over here. Now let me clear this point over here. Now fifth point you can write here. Look at here. This is the fifth point I am going to write here. The IR absorption band at 1620 per centimeter. This is also as a very recognizable point. 1620 per centimeter indicate or shows or suggests presence of what? Let me clear this point also. Presence of presence of carbon carbon double bond, carbon carbon double bond, right? And now the 6th point, carbon carbon double bond. The IR absorption band at 1620 per centimeter indicate presence of carbon carbon double bond of olefinic carbon carbon double bond of alkene you can write, of alkene. Olefin is the old name, now you can, better way you can write as a alkene. So that will, what we can call it as a, avoid the confusion over here. Now let us see the point number 6 over here. See here, 990, 910 per centimeter. Once again you can write down here the IR absorption band at 990 and 910 per centimeter shows presence of monosubstituted alkene, that is RCH double bond CH2. That is a partial structure we have arrived. Now let's see the next point. What is remaining? Find out the structure of the compound, means that organic compound. Let's see here, by considering all above points, we can assign the possible structures of the given compound. Now there is a possibility, right? Here we can write the structure like this, CH3, not CH3. Let me write here two structure, and that two structures are like this: CH2 double bond CH, then CH2 OH. Look at here, there are 3 carbon atom, 6 hydrogen atom, and what is it? 1 oxygen atom. Another possibility, we can write CH2 double bond C, then OH, then CH3, right? Look at once again, 3 carbon atom, 1, 2, 3, 6 hydrogen atom, and there will be a this. But this structure number 2, it can undergoes tautomerism. After the tautomerization, this is an unstable compound, this is enol form, and that enol form goes into the second one. Which one? Second, let us see here, it will give CH3, C double bond O, and CH3. That's the compound which we are going to get over here. So now if you see the structure number second over here, this one, it is converted into as a ketone. The possibility of second structure is ruled out because that enol form is get converted into as a keto form, and therefore the structure number first is a right structure or the correct structure. Why? Let us see here. Now look at here, carbon carbon double bond, and that carbon carbon double bond, the value is around 1620 per centimeter. Now as we know that there is a OH, and OH value is around 3300 per centimeter, and we know that this is a monosubstituted olefin, and that's why the value is 990 and 910 per centimeter, and in this way we can easily solve the problem by using this type of the compound, right? So I think with this, let us stop today here. Remaining we will see in the next lecture. Thank you. Have a nice day.